Okay, hello everyone. So we are back with another set of video notes. So today we're going to be doing an error analysis. So the other day I gave you a worksheet reviewing all of the things that we have learned in our unit 6, which was relating to statistics. So with all of that, I decided to look through look through your work and just look for some common mistakes. Now, if you recognize one of your worksheets or one of your problems used as an example, do not feel bad, because I chose specifically some problems that had common mistakes. So mistakes that are being shown today, the errors that I'm going to be analyzing today, were common mistakes that a lot of students made. Not just one particular person. A lot of students made these errors. And what I like about doing error analysis is I really like doing these because it gives us a chance to kind of look at what mistakes were commonly made, and so that we can learn from those mistakes, and it's all part of that growth mindset and moving on from those mistakes and knowing, okay, so I can learn from that and use it next time when I run into another math problem like that, and not make that same mistake again. So doing an error analysis is a really good thing to review, and since we are coming up to our unit assessment very, 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 very soon, this is the perfect time to do that. So let's go ahead and get started. So our first one you'll see is a histogram. So upon looking at this, at first you think, okay, so this histogram looks correct. Now, if you remember histograms, and please go ahead and copy down what I am writing as we go along in this video, and remember, you are welcome to pause or rewind at any time. Histograms are graphs that show us frequency, how often a number or value occurs in a data set. Okay, so if you remember when we were doing histograms in our notes in Khan Academy, I would always ask, how many times do you see a number between 0 and 20 occur in this data set? So if you look at this, what this student did, so at first you say, okay, so this person got it right. They got 16. This person got 16, 5, 13, 12. Okay, so those are all numbers that fall in between 0 and 20. And then between numbers 20 and 40, okay, it looks like this person also got 31, 32, 24. So those are all numbers that fall in between 20 and 40. So this person got it right and put the bar up to 3. Now when we get to here is when we kind of get a little bit lost. Okay, so let's go ahead and make that correction down here. So if you move down in your notes, you'll see that there's a new graph for us to work with. Okay, so we'll go step by step with this. So easiest way to do this is just go through all the data and just look for the numbers that fall in between those increments. So numbers between 0 and 20, we have 16, we have 5, 13, and 12. All of those numbers fall between the increment of 0 and 20. So we can bring our bar all the way up to 4. So that's how often that number occurs in our data set, or numbers between those increments occur. Okay, now we need to look for numbers that are between 20 and 40. Okay, so let's see what numbers fall in between 20 and 40. Okay, so we have 31, 32, 24, and looks like, okay, that's about it. And make sure whenever you're creating a histogram to double check and make sure, is there any other numbers in the data set? Because it is, as you can see, this data set is not put in order from least to greatest. Now it would help if we would put our numbers in order from least to greatest, so we can kind of see where everything falls. So if you want to go ahead and put your numbers in order from least to greatest, that's fine. That makes things way easier. But just for the sake of time, we're just going through this and we're just going to see how we're going to do this properly. So 31, 32, 24 all fall in between 20 and 40. So that's approximately, that's 3 numbers. So our bar is going to go up to 3. Okay. Now, this person, this is where I said, okay, they did fine to here. Then we start kind of running into some issues when we go over here. So let's see. So the numbers between 40 and 60. Okay, we have 47, 42, and 60. And it looks like that's about it. So, or wait, hold on, not 42. Actually, we only have 2 numbers because we're only going from 40 to 59, which I know can be confusing. So actually, that's my mistake. So see, this is why we have to make sure that we're analyzing our errors and making sure that we're going through this step by step. So this is not included. So I'm going to cross that out. And it's going to be 47 and 42. So there's actually only 2 numbers included in that data set, or in that bar. So the bar only goes up to 2 because it's between 40 and 59. Okay, now the numbers from 60 to 80. So now we can include 60, 67, and 77. So how many numbers is that falls in between those increments? Looks like there are 3. So let's move our bar up to 3. All right. Okay. And now we have 80 to 100. So obviously the rest of the numbers, 1, 2, 3, 4, we have 4 numbers that fall in between 80 and 100. So our bar is going to go up to 4. And there you go. So this histogram looks completely different from this one. So if we were to analyze what type of error this could be, so there are 3 types of errors that happen in mathematics. We have computational errors, careless errors, and conceptual errors. The more I say error, the more I think I'm saying it incorrectly, but whatever, it's fine. So you know what I'm trying to say. A computational error is an error where it is where the person incorrectly adds, subtracts, multiplies, or divides incorrectly. So meaning that you made some kind of computational error, like saying that 5 plus 5 equals 11 when in fact it equals 10. Okay, and sometimes that just happens, especially in math. Sometimes you're just going through it and then you just make a computational error because you're doing a bunch of math problems at the same time. Sometimes it happens, and that's okay. Now, a careless error, which can happen also very often, is an error that happens because you're either rushing through the problem and not paying close enough attention. And please copy these down so you know exactly what kind of errors happen in math, because it's not just in statistics. It happens through all topics in math, okay? And the conceptual error, this is one that I feel happened a lot when I was looking through these papers. Conceptual error is when the concept itself is misunderstood. So sometimes you misunderstand the concept of median or mean, or if you misunderstand the concept of, I don't know, one-step equations. It's a misunderstood concept. Okay? It's where you don't completely understand what the actual the concept behind the actual math problem, and so you make errors because of that. So if you look at this, it looks like this person actually knew what they were doing and they knew how to create a histogram. So it doesn't look like it's a conceptual error. I wouldn't say it's a computational error because there wasn't necessarily any adding or subtracting or dividing or multiplying involved in here. Now, would I say it's a careless error? I believe that's probably the kind of error this would be, because it looks like this person just kind of didn't take their time or just didn't double check their answer, or we're not paying close enough attention, so it became a careless error, which happens in math sometimes. But the way to avoid that is to just double check your answer. So go ahead and X off a careless error, okay?